We'll proceed in Jacobian in calculus and we will see the three style of Jacobian in little bit more detail. Jacobian, you are awesome, you are amazing. So, calculus, we are into commercial calculus, calculation of curl, calculation of flux, and now Jacobian. So all these factors, they come in kind of commercial calculus. If it is commercial calculus, then we will proceed in artificial intelligence. In artificial intelligence, we will see use of curve, we will see use of flux, and we will see use of Jacobian. We are not running away. Okay, so we will see how calculus is used in commercial, commercial calculus. How in commercialization, how calculus is used. So that is the fundamental. Okay, now three kind of Jacobian we are talking. One is called partial Jacobian, one is called cross Jacobian, and one is called full Jacobian. We have calculated surface area of a sphere through partial Jacobian. So partial Jacobian, where the surface area of a sphere, if I take any point P on the sphere, then dP by dx cross dP by dy, dP by dy, dx cross dP by dy. So, okay, so if I consider this x-axis, this is y-axis, this is z-axis, then if I have a xy plane, and I have a surface on top of it, I take any point P on the surface, then coordinate of P is x plus x comma y comma z. So dP by dx, if I consider position vector of P, then xi plus yj plus zx plus zk. dP by dx. Now this is called xz plane. xz plane. This is called yz plane. xz plane. yz plane. dP by dx. dP by dx means if this is the position vector at a surface point P, then dP by dx, P equal to xi plus yj plus zk, dP by dx, I plus dz by dy dx k, I plus dz by dx k. If you see, it has I component, it has k component. I component, k component. This means that this vector is in xz plane. dp by dy z z j plus dz by dy k. It is in dyz plane. What is meaning of dz plane and zx plane, xz plane and yz plane? dp by dx, consider it is a vector A. dp by dx is a vector. P, position P is a vector. dp by dx is a vector. Position dp, position vector P equal to xi plus yj plus zk. dp by dx is I plus dz by dxk. If that is true, then the dp by dx, consider this vector as A, dp by dy as B. If that is the case, then the A cross B is the area between vector A and B. If there is any vector A, if there is any vector A and there is any vector B, any vector, then it makes a surface, any vector. If I see this vector A and if I see this vector somewhere in 3D space, if I see this vector B, A and B, now if you take, it becomes a surface. The area in between this, what is in between this? If this is a vector, it has a magnitude of this much only. If this is a vector, it has magnitude this much only. What is the area in between? If this is a looks like this is not a rectangle, this is a looks like some kind of a triangle. Now parallel to this line, if I draw another line here, and parallel to this line I draw another line here, it becomes a parallelogram. If it becomes a parallelogram, then A cross B, it results in another vector. The magnitude of that vector is area of the parallelogram, and it results in another vector in the sense the unit vector. If results in another vector A cross B, the unit vector is perpendicular to this plane. So whatever this plane is, the unit vector is perpendicular to this plane. Okay, so dp by dx cross dp by dy would result in a kind of surface. So if this is xy plane and there is a surface at any point P, if dp by dx is one vector, dp by dy is another vector, at this point, algebra talks about infinitesimally small granularity. So at this point, the surface area is dp by dx cross dp by dy, its magnitude. And direction is whatever the vector, it results in unit vector. That is the direction. Okay. So direction would be perpendicular to the surface. So if this is the surface, here unit vector is like this, like this, like this. This is also called area vector. Everywhere area vector direction is different. So dp by dx cross dp by dy is a surface. It talks about a surface. dp by dx, that is I plus dz by dx, that is a numeric value. Not necessarily, but whatever it is algebraic. So I plus dz by dx algebraic, whatever, direction k. At any point x, then it will be a numeric value. Any point x, y, z, it will be a numeric value. So I plus dz by dx k is a vector. That vector crossed with j plus dz by dy k. That cross magnitude is the area at that point. And then cross whatever the vector is coming, that vector direction is the direction of the area. Okay, so that is the scenario for the kind of. So we got the surface area. A cross B is the surface area, but not certainly. dp by dx cross dp by dy, the vector I am talking about A is a velocity vector. dp by dx, it should be p only. So we are unknowingly, we are coming into a situation, we are getting velocity surface area. Means d surface area by dxy plane, dp by dx cross dp by dy is d surface area by dxy plane. To get the surface area, I have to multiply with the xy plane. So dp by d surface area by dxy plane, whatever it comes in, the magnitude is the surface, is the velocity surface area. Integrating it with dxy plane means dx dy would get the net surface area. This is how we calculate the surface area. Now, whatever this come as the dp by d surface area by dxy plane, it is coming as integrand of the integration where differential is dxy plane dx dy. The limit is the limit on the xy plane. The surface, if this is xy plane, on top of which there is a surface, the region on the surface for which we are calculating the surface area, that region will go and map on the xy plane. Okay, whatever the region it comes in, that limit is that region on the xy plane, not on the surface. If you see the surface, and for certain area I am trying to calculate the surface area, that area would go and map on the xy plane. That region is the limit region for the integration. So integration R, integration at the bottom we write capital R. So that is the limit for the region on the xy plane. fxy d dp by dx cross dp by dy, its magnitude, that is d surface area by dxy plane. Integration, that is becomes integrand, and differential to difference with xy plane, that is dx dy. Now, this integrand sometimes it becomes very complex. In that sense, we use parameterization. So for the parameterization, we use different coordinate system. So we last video, we took example of parameterization in a sense of a spherical coordinate system. So a spherical coordinate system, so we are in phase of calculating surface area of a sphere. So sphere is centered at the origin. If sphere is centered at the origin, the portion origin, then there is a xy plane that is cutting the sphere from the center. If there is a sphere and this is xy plane is cutting the sphere at the center. Top hemisphere, bottom hemisphere. So top hemisphere, if I take Cartesian coordinate, then it will calculate the top hemisphere surface area, whatever it is. Now, if this is the sphere, and if I am trying to calculate the surface area, then at any A, if I take any small region area A, if I take all area, I have to take on the surface only, not inside the sphere. This means the radius is constant everywhere. That is the radius of the sphere. Then what is changing? If I have the surface of a sphere, if this is a sphere, then if I talk only about the surface, then everywhere the radius is same. But what two things are changing? After all, it's an area, right? Then one thing, that is, there are three things in the spherical coordinate system: theta, phi, and r. Theta is the angle on the xy plane. On the xy plane, how much angle it makes. Whereas phi is angle from the vertical. It may go in xz plane, it may go in yz plane, both places, other places also. So from the, I also call it longitude. So longitude from the vertical, how much angle it is making. So if it is a sphere and I take any small area here, that small area, there is a vertical arc. So beginning, if this is very small area is there, the beginning of the area, end of the area, what is the angle? If this is the angle, if phi angle is made from the vertical, then this angle is d phi. Similarly, I have taken an area. If this is the sphere, I have this is sphere means this is the top. Little bit down to the top, I have taken a small area. That area at that location, if I make a cross section, it is a circle of radius r. So the angle theta. So the if I take a small area, one side is the vertical arc, other side is the horizontal arc. Vertical arc has variable phi, whereas horizontal arc has variable theta. Now we will not talk more than this. Now dp by dx cross dp by dy, d surface area by dxy into dxy is the net surface area. Xy would cut down. Now, if we are talking about theta phi plane, because r is radius is constant, so xy, as per xy, now here it is theta phi. If it is theta phi, then dxy, that is numerator, okay, xy plane is the numerator. It will be written as xy plane by theta phi plane into theta phi plane. Now xy cut down. Now it is d surface area by d theta phi plane into d theta phi plane. D theta phi plane will come as d theta into d phi, and this will come as it can be considered as Jacobian. D surface area by d theta phi plane. D surface area by dxy plane is dp by dx cross dp by dy. Now it will be dp by d theta cross dp by d phi. Now what is P? P is xi plus yj plus zk. As per the parameterization from Cartesian coordinate xyz to spherical coordinate system, now it will be A, that is the radius of the sphere, A sine phi cos theta I, that is x. I have many times I have demonstrated what is x. Okay, plus plus A sine phi, A sine phi sine theta j plus A cos phi k by d theta cross A sine phi cos theta I plus A sine phi sine theta j plus A cos phi k by d phi. Whatever comes in, get the magnitude and integrate with d theta d phi. What about the limit? Earlier the limit was if there is a sphere, this is xy plane, the sphere would go and map as a circular region in xy plane. This circular region, this is not a circle, region, full region, xy plane full region. It is not only circumference we are talking, full region. If we are talking about full region in xy plane, then x is from minus a to a, x is from minus a to a, then y is should also be from minus a to a. But we have seen that in independence of the variable, x, y are supposed to be independent to each other when we are talking about three dimensions. But if it is independent, it should be a rectangle, but it is a circle. This is how, this is the cause of the complexity, and we are going to a spherical coordinate system. In a spherical coordinate system, where r theta phi is the coordinate and xyz. In xyz, if there is a sphere, this sphere would map like a cuboid in r theta phi plane. If theta phi is there, in theta phi, if there is a rectangle, that rectangle would map to a circle in xy plane. So idea is to get a coordinate system, new coordinate system, where my circle would map like a rectangle if my coordinate is not providing a rectangle. Anyone would ask, is it the aim of the life that the limit should be rectangle? Yes, this is the aim of the life. That limit must be a rectangle. At least tends to that. Okay. So if I see a spherical coordinate system, the theta phi plane, theta and phi, they are orthogonal to each other. And the way we are taking that transformation function is x is the transformation function. What we are seeing is x equal to here xyz, here theta r phi, x equal to a is the radius of the sphere, a sine phi cos theta, y equal to a sine phi sine theta, and z equal to a cos phi. This is called, I have x, y, z, and this is called here, I have theta r phi. Then there is a capital T transformation function that comes into the picture. Capital T transformation function that comes into the picture. So x braces x comma y comma z braces close. Now it is equal to capital T transformation function braces open braces close. Beside that theta r phi. So theta r phi and x y z, they are related through transformation function T, capital T. What is capital T? That is x equal to a sine phi cos theta, y equal to a sine phi sine theta, and z equal to a cos phi. Now, if this is the scenario, then the limit is minus a to a, then y is square root of minus a square root of a square minus x square to square root of a square minus x square. That is the circle. It should be rectangle. Yes, it is rectangle in theta phi plane. What is the limit of that rectangle? So we have seen now the limit of that rectangle is, now if I say x equal to this, y equal to this, y by x equal to tan theta. Theta equal to tan inverse y by x. Okay. Now one limit is minus a 0, other is a comma 0. If that is the case, okay, then y is 0 and x is minus a, minus 0 something like we can say. So it is coming as pi. and plus is 0. So pi to 0 is the limit for x equivalent to theta is pi to 0. What about phi? Okay, if I take plus a square root of a square minus y square, a square minus x square as y, then y is y, okay, then y is a sine phi sine theta, a sine phi sine theta equal to the square root of a square minus a square sine square phi cos square theta. Okay. Now, if that is the scenario, then I can take a square root and it becomes now a. I can take out and a got cut everywhere. Now, if I take a square of it, then sine would go away. Sine phi would go away. Sine phi would go away in a sense that this side it is a square sine square phi sine square theta, and that side square root of a square. So a anyway all gone, a gone. One square root gone. Now it is 1 minus sine square phi cos square theta. If I take this side, then square phi I can take outside in braces. Sine square theta plus cos square theta equal to 1. Sine square phi equal to 1. Phi equal to pi. Then only it will become 1. Phi equal to pi by 2. If upper limit is positive square root of a square minus x square, lower limit is minus square root of a square minus x square, it can be considered as minus pi by 2 to pi by 2. So there is a rectangle where the theta is 0 to pi and phi is minus pi by 2 pi by 2. It is a pure rectangle. Now, whatever the cross product comes dp by d theta cross dp by d phi, calculate the magnitude, integrate with d theta d phi, and then get the full top hemisphere surface area. Multiply by 2, then get the hemisphere. This is called cross Jacobian. Why it is cross? Because we started with d surface area by dxy plane into dxy. Now, dxy is nothing but dxy by d theta phi into d theta phi. Xy is xy gone, and now d surface area by d theta phi into d theta d phi. Now, if I have xy plane, on top of it I have a surface, and now I have theta phi plane, xy plane we are cutting down. Otherwise, surface is dependent upon xy plane. If I take out xy plane, now surface is directly dependent upon theta phi plane. This is called cross Jacobian. This is our representation. This is our kind of nomenclature. So that is the concept of cross Jacobian. Someone can try. I tried doing it. It looks like very complex. I would retry. It looks like very. Is there any? Someone would ask, is there any way, other way, where we can? There is other way called partial Jacobian that we have already done. So someone can watch partial Jacobian to calculate the surface area of a sphere. What about full Jacobian that we will do now? Can we use full Jacobian to calculate the surface area of a sphere? Now we're talking about top hemisphere as per the xy coordinate system, because everything starts from the origin in xy coordinate system. But our sphere is centered at the origin. Now d surface area by dxy, numerator dxy is dx dy. D surface area by dxy, if we take, then what it would come? dp by dx cross dp by dy. dp by dx, that is d surface area by dxy, it came from dp by dx cross dp by dy. Okay. In cross Jacobian, it became dp by d theta cross dp by d phi. Now, dp by dx is I plus dz by dxk cross j plus dz by dyk. There is a famous cross this and it becomes minus dz by dxi minus dz by dyj plus k. Its magnitude would be dz by dx whole square, dz by dx whole square plus dz by dy whole square plus 1 square root. Now, x square plus y square plus z square equal to a square, then z equal to square root of a square minus x square minus y square. dz by dx is now minus x by square root of a square minus x square minus y square whole square plus dz by dy whole square. dz by dy is minus y square root of a square minus x square minus y square whole square plus 1 whole square. Now it becomes x square by square root of a square minus x square minus y square plus y square by square root of a square by a square minus x square minus y square. Here also x square by a square minus x square minus y square at the end plus 1. If I settled it down and calculate the root, it becomes a by square root of a square minus x square minus y square. This becomes integrand dx dy over the region where x is minus a to a. Y is from a square root of a square minus x square to square root of a square minus x square because it is a circular region with radius a. So y is from minus square root of a square minus x square to square root of a square minus x square. Now now we can, since we cannot calculate, if I keep a outside, it becomes 1 by square root of a square minus x square minus y square dx dy or dy dx. Now it becomes difficult to calculate this. Now here we use parameterization, different coordinate system. Let's use polar coordinate. Earlier we used spherical coordinate and the surface area was denoted by theta and phi. Now if I take polar coordinate system, then we are, if polar coordinate system means xy plane would be now have counterpart as theta r plane. So xy plane on top of it we have a surface. Now xy plane is depending upon theta r plane. Now xy plane, if there is a circle, then on theta r plane again there is a circle, but limit would be different. The way we saw in theta phi plane. Okay. Now x equal to r cos theta. X equal to r cos theta and y equal to r sin theta as per the xy coordinate system to theta r coordinate system. If that is the case, if that is the case, then now we have d surface, we have the net is 1 by square root of a square minus x square minus y square. Square root of a square 1 by square root of a square minus x square minus y square. This is the integrand. If I replace x and y with r cos theta and r sin theta, it becomes 1 by square root of a square minus r square. A is outside. Now dxy can be replaced with dxy by dr theta into dr theta. So this becomes Jacobian. dxy by dr theta becomes Jacobian into dr d theta. What is dxy by dr theta? Okay, dxy by dr theta as per the Jacobian concept dxy by dr theta. If I take any point on the xy, now if this is xy, this is r theta, consider this is r theta. On top of it there is a xy because xy is dependent upon r theta. Similarly, z was dependent upon xy plane. Earlier, z was dependent upon xy plane. Now, xy is dependent upon r theta plane. Now, x equal to r cos theta, y equal to r sin theta. If I take any point P here on xy, then, then it is something like kind of d. Now we are calculating dxy by dr theta. So dxy by dr theta is as if the surface area on xy by d r theta means on xy it is a rectangle, by it is a circle, and r theta is a rectangle. If I make a unit change in the rectangular area on r theta plane, how much unit change it makes in a circular region on xy plane, the dxy by dr theta. If I have d position, if I take any these, if I take any position vector p on surface, then d surface d surface area by dxy by dp by dx cross dp by dy. Now, if I take any point position vector p on xy, then dxy by dr theta is dp by d theta cross dp by dr. Now, p is xi plus yj. Okay, so same way it becomes dp by d theta cross dp by dr. So dx by d theta I plus dx by dy by d theta j cross dx by dr I plus dy by drj cross product, that is the Jacobian. Dx by d theta I plus dy by d theta j, that is position vector by d theta, cross dx by dri plus dx by dy by drj. This is again position vector by d theta r. Okay, now means dp by d theta cross dp by dr. Now, if this is the scenario, then someone calculate the cross product. It will be determinant of a matrix dx by d theta, dy by d theta, dx by dr, dy by dr. That is dx by d theta into dy by dx by d theta into dy by dr minus dx by dr into dy by d theta. Okay, if someone calculates it, then the top row, it will become dx by d theta. X is r cos theta by d theta r minus sin theta. Dy by d theta, there r cos theta. Dx by dr, it becomes cos theta. And dy by dr, it becomes sin theta. If you do calculate determinant, it becomes r in braces cos square theta plus sin square theta r. R is the Jacobian. So r d theta dr is a famous by 1 by square root of a square minus r square. R is a is outside. Now r by square root of a square minus r square dr d theta. That will be minus okay, minus a square minus r square minus 1 by 3 a square minus r square to the power 3 by 2. I believe, okay, r by square root of a square minus r square. Okay, it would become minus square root of a square minus r square, the integration. Because if I differentiate, it becomes now minus is anyway there, and then 1 by 2 into a square minus r square minus 1 by 2, and then minus 2r minus 2r, then minus go on 2 go on r. So r by square root of a square minus r square integration is minus the square root of a square minus r square. That is the integration. R is from where to where? Theta is from where to where? Now someone would say that if you have a circular region, then r is 0 to a and theta is 2 pi. Let's try. X is minus a to a and y is square root minus square root of a square minus x square to square root of a square minus x square. Let's try y. Then y square equal to a square minus x square. X square plus y square equal to a square. That is a square sin square theta plus a square cos square theta. A square cos square. Now r square cos square theta plus r square sin square theta equal to a square. Then it becomes r equal to a. Okay, so top is a, bottom is minus square root of a square minus x square minus a to a. What about x is minus a to a? Now x equal to r cos theta, y equal to r sin theta, y by x is equal to tan inverse theta. Okay, y by x equal to tan theta, theta equal to tan inverse y by x. Now a is minus a to a, x is minus a to a. At that location y is 0. Okay, then it becomes minus 0 tan inverse plus 0 tan. So pi to 0. So theta is pi to 0. Theta is pi to 0. and r is r is theta is pi to 0, and r is r is minus a to a. Now here we have minus square root of a square minus r square minus a to a. If I keep a there, then it becomes minus a square minus r square. If I keep a there, then it becomes 0. If I keep minus a there, it becomes 0 again. Okay, so there is something lacking. Okay, what we can try now is the limit what we are doing, the y what we are taking, will take from 0 onwards, not the minus 2. We'll multiply by 2. So it becomes 0 to a. If now limit is 0 to a square minus r square, then a if it comes, then it is 0. 0 it comes, then it becomes a. A is anyway outside a square. So it becomes a square. Simple a square. And now theta, d theta integration is theta. Pi to 0, it becomes pi. Pi a square is the surface area of a sphere. But we had taken top hemisphere. In that also we had taken the top half, not the bottom half. So 4 into pi a square. 4 pi a square is the surface area of a sphere. Someone can try this. Probably no one would have tried this way. So this is the full practical way calculating. So we talked about cross Jacobian. Someone can try what formula we have given. Through similar formula, we calculated the surface area of a sphere through the full Jacobian. Through partial Jacobian, anyway we have done it 4 pi a square. So all three way we have calculated the surface area of a Jacobian. So someone can try, and please do support us. +91 is the India country code. 9483160610. 9483160610 is the telephone number of for our telephone number, and +91 is the India country code. Someone would try and see if you are able to get the surface area of a sphere through partial, full and cross Jacobian. We have already tried calculating the surface area of a cone that would not be available anywhere else through partial Jacobian. I believe through full Jacobian also we have tried, and cross Jacobian we have tried. So someone can check that. Okay, we will move to the calculating the volume of the sphere through the full Jacobian. So that we will try. We'll try with the partial and cross also, but that is the idea. Post the calculus, we will start the artificial intelligence much awaited, and we will see the power of calculus, and then power of calculus, because machine learning or artificial intelligence, it starts from probability. The main science behind the machine learning is the like main science behind the mathematics what we are talking here and there is algebra. Calculus comes in the helping the calculation of the algebra. Similarly, there also it will come to help the calculation. The base of the artificial intelligence is statistics, or you can say probability. So that statistic generally people place it in algebraic equation. To solve it, then vector and calculus and those things will come into the picture, and we will have commercial calculus. So when commercialization comes, it will be attractive. But base is these things only. If someone do not understand cross Jacobian, partial Jacobian, and full Jacobian, he would land up in trouble in future. So that we will see.